Earth Science Institute. Our mission is to educate, inspire, and support geologists worldwide.
I am William, or Bill Little. I am the owner and principal geologist at W.W. Little Geological Consulting. Our primary focus is professional training courses and training courses for students. In terms of tangible professional accomplishments, there are two things that come to mind. One actually does go back to my graduate school days, my PhD days, when I was involved in some of the early attempts to apply sequence stratigraphic concepts to thick continental, primarily fluvial successions. I didn't then, and I still don't use the sequence stratigraphic terminology, as I really don't think that applies very well. But there are some concepts that I do think are quite applicable. Probably most of what I have done would now fall under the banner of distributed fluvial systems, which has become a very popular topic, and it is something that I continue to work on. The other is a little bit more controversial. For 6 years, I was a mapping geologist for the Missouri Geological Survey. I mapped a large number of quadrangles, and I suggested that these features that for 150 years or so had been referred to as Pennsylvanian-filled sinks, that is, sinkholes that are filled with sandstone of Pennsylvanian age, that in reality they were more likely to be Ordovician in size valley fills. And that's a significant change, and it still remains a bit controversial. It's a long story, and I'll leave that for another time. The next question that I was asked was, how has the field of geology changed over the course of my career? And without doubt, the biggest change has been related to advances in technology. When I was in high school, I was still using the slide rule. My senior year, for homework only, as an experiment, they allowed us to use calculators. Then when I got into college during my undergrad years, there was the great debate over which was superior, the HP reverse logic or the TI straightforward type of calculator. You know, I was a TI 59 guy. Also, during my undergraduate years, I became acquainted with punch cards, which were the state-of-the-art computing at that time, and I was fascinated to watch that row of cards move along a conveyor, the things that it would accomplish. By the end of my undergrad years, we had the Apple labs on campus. Personally, my first computer was an Apple IIc. It was the first portable computer. That's one of the reasons that I got it. I could put it into a bag, throw it over a case, and throw it over my shoulder, take it to and from campus. I had a monitor at home and another monitor on campus, the old monochrome green monitors. The computer itself had a whopping 128K of RAM, no hard drive. You would insert a 5 1/4 floppy to load the software, and then you would pull that out and put in the next floppy, which had your files and where you saved your data. Now you go into a geologist's office for a major corporation, and computer monitors just line the wall. And in seconds, they can push a button and they can generate a complex cross-section from a multitude of data, something that would have taken us days or weeks in the past using colored pencils. The largest monitor I've seen is a 14-foot diagonal at the University of Utah. Quite an amazing piece of technology. The same thing with finding information. My undergraduate days, all the way through graduate school, the primary way to do that was to go to the library and to search through the card catalog, looking for a particular book or books on a particular topic. With the advent of GeoRef, that was a huge step forward, where we could put a floppy disk into into a computer, and we could do a Boolean search on whatever terms we desired, locality, formation name, topic, and what would come up is a list that we could then print out that had virtually every paper that had ever been published on that topic. Now, of course, I'm sitting here in front of my laptop, and at my fingertips, I have virtually the entire knowledge of mankind available to me. There are a number of ways in which that can be searched. I can use complex databases, and a lot of it I can simply do through simple searches on the computer. Now, I think that this has both advantages and disadvantages. The advantages, of course, are all the material that is available to us. And another one, well, I remember when I was younger, we were told how much easier computers are going to make our lives. They really have not. I think that they've actually made things much more complex, but they do allow us to do more. Things that we would have in the past sent off to others, we can now do ourselves, and we can accomplish more in the same amount of time. But on the other hand, I think that it has become easy enough to enter data and push a button and get a result that in some cases we are learning our ability to, or losing our ability to truly understand what it is that we are doing, and that maybe we don't understand what is behind the product that we're generating as well as we did at one kind. Let's see. And with that, I'll go on to the last question. The last question is, what would I say in terms of promoting the importance of geology, and what advice would I give to an aspiring geologist? For the importance of geology, I would probably give the same response that just about any geologist would, that geology impacts virtually every aspect of our lives. When I was teaching at BYU, Idaho, one of the courses that I offered was an earth science class for education majors. The first week of that class, they didn't yet have enough knowledge to do a lab on rock ID or any other topic, and so what I chose to focus on was a lab that was titled something like "The Importance of Geology in Your Life." And one of the major parts of that lab was for these students to observe their surroundings, their personal, the things that they were wearing on their body, the things that they had at home, their transportation, what they could find in the geology building, and to make a list of everything that they could find that had come from some type of geological product and what that product was. And then later I'd have them expand that and, well, what is involved in producing those products and so on. And it was really quite an eye-opener for them that everything from the clothing they were wearing to the food that they ate, transportation, the materials to construct the building that they were in, virtually everything had some tie to a geological product. When I was living in the state of Missouri, there was a bumper sticker that was quite common that said, "If it can't be grown, it's got to be mined," and that had quite an impact. There's a lot of truth to that. Another reason to be concerned about things geological is the way that our lives are impacted by the environment. We're all concerned. Every one of us is concerned about how we impact the environment and how the environment impacts us. Whether it's something such as, where do I build my house? Do I put it on a floodplain? Do I put it at the bottom of a hill because it's quite beautiful? In a natural disasters class that I taught, I would emphasize that places are beautiful because of active geological processes, and everywhere has its own hazards. And sometimes at the end of the semester, a student would ask if there was any place where they could safely live. And I tell them, well, yes, but you do have to choose your poison. But on a larger scale, things such as climate change. We all have our opinions on climate change. It is a controversial topic, and I have found that regardless of which side of the topic a person is on, it is unusual for them to be able to defend their position. They're simply repeating things that they have heard from others. So if you do have a strong a strong position on that or some other controversial topic, can you defend it? Or can you point out to someone else why you disagree with them? Other than it is what you heard some individual who you trust say. And so geology does really impact every aspect of our lives, from the materials to the environment around us. And so, in terms of the of promoting the importance, that's where I would put it. The other part of that question: what advice would I give to aspiring geologists? I used to take my students to an event called the Rocky Mountain Rendezvous in Laramie, Wyoming, at the University of Wyoming, that was sponsored by energy companies. And one of the first things that they would do is to have a roundtable discussion where initially, when it was small, it was actually a round table that we'd all sit around. Later, they would sit on the stage, across the stage, and the audience was in the auditorium. But they were allowed to, the students were allowed to ask any questions that they wanted to ask. And invariably, one of the first things that was asked was, what classes should I take? And almost always, the response by the recruiters was, the first thing out of their mouths was, learn to write, learn to think. They would indicate that we can teach you the software. We can even teach you some of the geology, but it's very difficult, and we don't have the time to teach you to write and to think. And so the advice that I would give to an aspiring geologist or anyone else is develop strong communication skills, both verbal and written, and learn to think and to understand and to analyze, rather than simply to memorize and to repeat. Something that I might add to that is, students would often ask me, is this right? And I would tell them, this is geology. I'm not really looking for right, I'm looking for reasonable. Does it fit the data? And does it not violate geological principles? And I would sometimes emphasize that, two, and I know this drove my engineering students nuts, but 2 + 2 is somewhere between 3 and 5, maybe 1 and 7. Keep your options open, and learn to think and to analyze and to question what others have come up with. Question everything, and again, learn to write well. And so, with that, I think that I have responded to the questions that I've been asked by ESI, and I will end it there.